Tim and I have an intense interest in the subject. For me, I got my first telescope at age 9. And I was already out there, one of those weird kids that was out under the stars making my own, drawings of what I was seeing. Now, Tim, you came to it a little bit later, interested in astronomy.
A week ago.
Okay. We know a lot about this stuff. So anyway, first part of the program, Tim is going to give a sort of a basic introduction of astronomy. I mean, there's a lot of common facts that people just don't think about. So he's going to give sort of a basic overview, and he's going to turn it over to me for a little bit to start off the Oddities segment of the program, and then I'm going to turn it back to Tim. So, ladies and gentlemen, I'd like to present Tim Campbell.
Yeah, actually, I've been in the hobby for about 3 years, but I've always been interested in it. A couple months ago, back June 5th, we had what is known as the Venus transit, where the planet Venus crossed between the planet Earth and the Sun. And astronomy club that I'm involved with in Cleveland State and Baldwin Wallace held an event down at Edgewater, and we had approximately 7,000 people show up for that. So there's definitely a lot of interest in astronomy here in the area, which is very, very cool. And now with Curiosity on Mars, that's kind of slick. And then, of course, the Large Hadron Collider in Switzerland finds the Higgs boson, which we all know as the God particle.
Actually, it's the goddamn particle?
It was actually known as the goddamn particle, and it was shortened for the sake of literature. Physicists have a strange sense of humor. Astronomers don't seem to have much of a sense of humor at all, but they're very literate, or literal. Anyway, amateur astronomy, space oddities, and other cool stuff. And let's see if this will work. All right, cool. Professionals versus amateurs. Essentially, the pros get paid to look at the stars, and amateurs like us, we get to pay for the privilege. And we can spend a lot of money on this hobby. No question about that. The professionals, however, have better toys. This is a panorama view of the European Southern Observatory. It's located in Chile on a mountaintop, a couple of mountaintops. They have a number of different telescopes there, including, let's look at the notes. They have a dozen or more scopes, including the ELT, which is the extremely large telescope, which features a 40-meter mirror, which is about 120 feet in diameter. So mine, for example, is an 8-inch. So they do a little bit more. It's interesting just to figure out how to handle all this. All right, that's a picture of the ELT, the 40-meter scope. And then it's very easy to get to. You simply fly to Santiago, Chile. You take another plane either directly up to Calama, or you can go to La Serena and then another plane to Antofagasta, which served with bread is very good. And then you take you drive up here to the mountain, climb a mountain, and you're there. So it's a piece of cake. Anytime you want to visit, you just give them a call, go down there, and they'll give you a tour. This is some of the things that they've been able to see. This is a spiral galaxy located just north of the Big Dipper. If you look at the Big Dipper as like this, you go to the last two stars and up a little bit, and that's where M101 is. It's a very detailed shot of a spiral galaxy that's facing us. And it is, I believe, I'm not going to say, I'm not sure exactly how far away it is, but it's at least, there are two other galaxies by the Dipper that are about 15 million light years away, and those are fairly close. So this is a good bit farther away. This is a shot of the Great Attractor. These are all, well, not all, these are all galaxies except for these guys. Those are foreground stars. The Great Attractor is a gravitational anomaly, which just means that nobody knows what the hell it is. It's in the Centaurus supercluster, which is a cluster of clusters. And a cluster would be a bunch of galaxies together. So there's a whole bunch, but essentially the central mass of this puppy is equal to tens of thousands of Milky Way galaxies. So they call it the Great Attractor because it's basically the center mass of this supercluster, and everything in the supercluster is related to it. So that's a shot again taken with the ELT, and then this is a closer shot, wider view of the attractor. And then this is into the eyes of the Virgin. We don't see them often anymore, but what we have is two galaxies. Why not? I said other astronomers don't have a sense of humor. Anyway, these are galaxies. This is a dust cloud. The center mass of the galaxy, which we'll talk about later, it surrounds a black hole. And that's another shot again by the ELT. And then everybody's fan favorite, the Hubble Space Telescope. This puppy is in orbit over Earth. It's approximately 307 miles up. And we've all, I'm sure, seen many of the pictures that have come back from this guy. It's magnificent what this has done. This is one example of a scientific theory that has been confirmed. It was kind of confirmed earlier, but gravitational lensing is a way to use the gravity of a mass. Basically, a bunch of galaxies here are curving the mass of a galaxy in the background, which would be this guy, this guy, this guy, and I think up over here. That is what I just pointed out is a single galaxy that's located behind these galaxies. And there's a whole talk in itself on gravitational lensing, but essentially it's a way for us to look back in time more than 10 billion light years, or which would be more than 10 billion years. And that's something that the Hubble has given us. It's enabled us to see almost back to the beginning of time. And then this is probably the coolest shot. Everything you see on here is a galaxy, representing hundreds of billions of stars in each one of these little dots. And this goes back, I'm reaching and I'm thinking that this shot goes back somewhere around 10 billion light years. Somebody else may know the exact figure on that, but it's going out a heck of a long way. And that's again a shot from the Hubble. But amateurs, we are not slouches. We've made many very real contributions to astronomy. There have been discoveries of comets, asteroids, and even supernovae, which I guess would be supernovas. The Australian Anthony Wesley, he discovered the results of either a comet or a meteor hitting the planet Jupiter. Let's see. Then we have David Levy, was co-discoverer. Basically did it on the same night of the Shoemaker-Levy comet that hit Jupiter in 1994. They discovered the comet in 1993. And this is a shot. This is Jupiter, and this is a shot of the explosion of this comet hitting the planet, which was kind of cool. And then the Australian Thomas Bock has discovered a bunch of supernovae. This is one, I think, where's the supernova in here? I think, if I'm not mistaken, this here is the supernova. But I'm not 100% sure. It's just been a picture I put in there. Who knows? And then my favorite, Hanny Van Arkel. She is not actually an astronomer. They posed her next to the telescope. But Hanny is a biology teacher in Holland, or the Netherlands, however you want to look at it. She's a fan of the rock group Queen, and she was on Brian May's website, and she read a comment by Brian May that talked about this group called the Galaxy Zoo. Now, the Galaxy Zoo is a group of astronomers who got together and said, you know, we're getting all these pictures, all these things from the Hubble, and we can't see everything, and the computers can't spot everything. Computers are programmed to look for specific things. They miss. If they're not programmed to look for something, they miss it. So why don't we take these pictures that are coming back from the Hubble Why don't we send them out to just ordinary, everyday people like you and me? And if we send them out and these people look at them, and if they see something that just looks odd, they can write in, and then we can take a look, get a closer look and see what the heck they may be looking at. So Hanny me an article, gets a picture. She joins. She says, wow, what a cool idea. And she joins. And this is her original, the picture that they sent her. And she's looking at this, and you basically have a galaxy over here and some foreground stars and a galaxy, but what looks like an elliptical galaxy that eventually will collide with this and become a spiral galaxy and so on and so forth. All kinds of cool stuff, but she's looking at this and she's, what the heck is this? Looks like a frog in the picture. So she didn't know that, nobody knew what it was. So she writes to the Galaxy Zoo, to the astronomers, and says, all right, I got this picture. What the heck is this thing? Anybody know? Well, nobody knew. So that got the professional astronomers excited, and so they turn the big guys to it. They get to the Hubble, and they turn the Hubble on this puppy, and this is what the Hubble showed them. As it turns out, this is hydrogen gas. And it's basically a blob of hydrogen gas somewhere in mid-space, somewhere between us and this galaxy. It's not part of this galaxy, it's not part of us, it's just a blob of hydrogen gas floating through space. I told you astronomers are not too imaginative. They call it a voorwerp. Voorwerp is Dutch for object. Okay. But the cool part is that they then named it Hanny's voorwerp. So anytime there's any literature on this, there's a scientific paper put out by the astronomers, and her name is in it as the discoverer of Hanny's voorwerp. So that's something that I thought was pretty cool, and it's an example of something that an amateur can do, and she's not even an astronomer, a biology teacher. Now she's got her own website, her own blog. She travels the world. She's been interviewed by various TV stations, all because of this. And all because of Brian May, who doesn't get any royalties out of it. So the Galaxy Zoo has expanded. They said that was such a cool idea. Let's start looking for supernova. And what you have here is a picture of a supernova as it's in its early stages, its peak, and as it's fading. So if you ever want to get involved, the Galaxy Zoo is galaxyzoo.org. Go to that, sign up, they'll send you pictures, and who knows, maybe you can be the next Hanny's voorwerp, or Hanny's object. So now we get into local astronomy, what we do, clubs, classes, where we do it, and how to get into the hobby. And it is a hobby. We do it for enjoyment, for pleasure. I'm a member of this group, the Cuyahoga Astronomical Association. We're a bunch of guys who are very much out of focus. This is a shot of we have an observatory area out in Medina, southwest Medina, which is kind of a dark area. And we go out there, we have a building in the background with stuff where we can put our scopes and that sort of thing. So this is just a group setting up for a private star party. We also do, this is our meeting house, meeting room. And this is that the barn? No, that's the meeting room. And then we have our own little observatory. This is a 16-inch scope, and a couple of the members are adjusting it to get that ready. We do private star parties for ourselves, for members, where we can stay there all night. And then we do public star parties. It's kind of a courtesy for Medina, but also as an outreach to get people involved in astronomy. In fact, we did one last night. We generally time it for what I call a moon night, but a night where the moon is visible, so that when you come out at 8 o'clock or 9 o'clock, there's something to look at before it gets dark. But last night, for example, we had about 15 telescopes out there, and there's probably about 50, maybe 60 people who came out, and everybody's very helpful. We show you what we know, and we my scope would be on the moon because I can find that. Somebody else would have something, a cluster, or double stars, that sort of thing. So, and you know, so it's a public event. We bring out, you know, bring out the kids. We got the little kids who have little stools, and they're lifting them up, and no, this is the moon, and this is this, and you know, so it's a lot of fun. But it is something that we do as an outreach and as a kind of a payback to Medina, because they let us use this facility. Here we are setting up for another public star party. This guy is certifiably insane. We'll show that in a couple of seconds later. Again, we're setting up for the party. Again, this I think was a private one where we just got out in the field, and you know, we'll go out there and observe. You know, we have an email list, and you know, hey, it's a clear sky. Anybody want to go out to leave the house? And you know, there'll be maybe 2, maybe 10 people out there, and we'll stay there till, you know, 1:30, 2 o'clock in the morning, and observe until the dew kills us. Here's some of the pictures. Some of the guys get into astrophotography, and this is some of the pictures by some of the CAA members. M17 is a nebula, the Omega Nebula in Sagittarius. Then we've got a comet. Joe Goliath took this shot. And then the moon, everybody's fan favorite, Jim Gilbert. And then this is my favorite, not just the picture, but the object, M13. What you're seeing here is between 300 and 500,000 stars that are gravitationally bound to each other. Physicists and astronomers use this to determine, or to help determine, the age of the universe, because every star is involved and has been there since they were born. They can tell how far along on the sequence of burning their fuel the star is, and it's really cool to see in a telescope. Very, very cool to see. Well, this is a good picture by Joe. And then we have Saturn. And it looks like that when you see Saturn in a telescope. It looks like a picture. Yeah, people will look in my scope and say, no, that's not real. You put a picture on the end of the scope, didn't you? I said, well, yeah, of course. You know, but yeah, that's Saturn. And there's other groups. Cleveland Astronomical Society is kind of a dinner and lecture group. They don't really do telescopes. They sit around and talk about astronomy, and they bring in speakers and so on. I'm not sure what the dues are there. Our dues are $25 a year. And for that, we have a meeting every month down at Rocky River Nature Center. We bring in speakers. Some are really good speakers, like Jeff Landis from NASA. So you get good speakers, and then when we can't, somebody like me gives a talk. And then we have Geauga County just opened this guy up, the Observatory Park. It's a bit of a jaunt, but it's a very nice dark area, and it's a really nice facility. Some of us went over there for the meteor shower that was a couple of weeks ago, and it was pretty cool. You could see Andromeda Galaxy naked eye, which is very, very difficult. But there it is. Wow. So that's another facility. This is the Observatory Park on their opening day, their grand opening or what have you, their dedication. They have a seismograph out there. I mean, they're doing some real astronomy. This is they're building at night. They've got the light set to go downward, and they have red lights, so you can find your way around, but it doesn't interfere with the sky observing. They have a working seismograph, and they're building a weather station, and they have pipes in the ground. Kind of cool. It's still under construction. They're still working on it. It's open, but they are doing stuff. And then you can do classes, and if you really want to learn about the hobby and the science behind it, Case Western has their Science of Origin Scholar Series, which I've been doing for the last 2 years. $150 for 7 lectures, and it's an hour lecture. It includes dinner and parking. And they're world-class people. We've had Haile Selassie, the guy who discovered Artie, from the Museum of Natural History. We've had Evelyn Gates, astrophysicist and CEO of the museum. and a whole bunch of very, very high-end lecturers come in and talk. And then they do, the Museum of Natural History does their Frontier of Astronomy lecture series. It's 4 lectures. It's once a month during the school year. And that's also very good. Again, they bring in world-class people who talk, it's astronomy related. The case one, it can be anything. It'll be evolution, biology, geology. The upcoming session, there's going to be 3 lectures on plate tectonics. So, I should know how earthquakes happen after that's all done. And BW, Baldwin Wallace, has Friday night lectures during the season, during the school year. And then they open, when it's a nice night, their observatory. They've got a 13 and 3/8-inch refractor telescope, which is this guy. And you go in there and it's like going into an old movie. You literally crank this thing around. Down here there's a couple of wheels. You just do this to move the sucker. And then the roof moves around. I mean, it's very cool, except that it is in the middle of Berea, and you do have a lot of ambient light. But it's still, so it's pretty cool. You can see a lot. So, how to get into the hobby? Join a club. Buy a scope and learn the sky. And you can do it in either order. I bought the scope, I joined the club, and I still haven't really learned the sky, but I'm working at it. The best way, if you don't know anything about scopes and you're not sure, is to join a club or come out to one of our public star parties and talk to the people. And you can get a handle on where you want to be budget-wise, size-wise, mobility-wise, because there's all kinds of things to get into. You can get a starter telescope for under $200. These are 3 scopes, and each of them is under $200. This one you can use as a planter or a bomb. Versatility is important. If the budget is low, you've got to stretch $1, This is not a starter scope. Remember, I mentioned this guy's certifiably insane. This is a 20-inch mirror, and this is a ladder, which you have to use to get up to the eyepiece. If you were to buy this new, it'd be between $15,000 and $20,000. He built it himself. Took him 5 years, ground the mirror himself, did all the woodwork. This thing it's not only an outrageously superb telescope, it's also a work of art. To see the woodwork on this thing close up is mind-boggling. And I don't know if he's on medication yet, but he should be. He's a great guy. Paul's a great guy, and like I said, it's about a $15,000 investment with a 20-inch mirror. This is my old scope. The whole investment was under $2,000, but I can only use it during the day. Can't see stars. It's kind of this one. Yeah, I'm observing clouds. Oh look, white. This shot was taken down at Edgewater during the Venus transit, and there's a solar filter on the end of this so that I can safely look at the sun and not have my eyeballs fried. There's 2 types of telescopes. There's refractors and reflectors. And the refractor, you have the standard type, which I'll show you in a second, and specialties, which are what we call a personal solar telescope. It's designed specifically for looking at the sun. And then the reflectors, there's 3 types, and we'll go through those. And there's advantages and disadvantages to each, and that's why you come out to a club and look. It depends on your budget, what you want to look at. You want to look at the moon, planets, deep space, clusters, galaxies, and being able to take it out easily. If it's just going to sit in the closet, then kind of useless. But so you kind of want to decide what route you want to go. This is the main type. This is the first type of telescope. It's a refractor, and essentially light is entering an object glass and going through the tube to a smaller piece of glass back here and then to your eye. So this is a very simple thing. The advantage is that it's very cost effective. Disadvantage is that you have to have a long tube to see a lot. So if you remember the shot of the Warner and Swayze one at Baldwin Wallace, that is a 13 and 3/8-inch diameter main glass, but the tube itself is about 14, 15 feet long. So No, it's got a little tough to carry around. So but on the other hand, again, you can get a nice starter refractor telescope that you can see the moon and various planets, and it's a very cost-effective way of getting into the hobby. Here's a refractor which nobody can get at. This was built in 1874. This guy here is Gary Cater. He's the head of the astronomy department at Baldwin Wallace, and this is his personal telescope. He brought this out for the Venus transit. I mean, you can see the tripod and everything is very old school, but it's superb and it's big, and it does a very good job. And this is a specialty telescope. It looks like it's like a little mini scope, but what it is a personal solar scope. It's equipped with a hydrogen alpha filter, and it's designed to see the sun, to watch the sun. With I can see the sun, I can see sunspots, but I can't see much else. Whereas with that, I think I've got a picture coming up of what you can see with a solar scope. But then we get into the reflector. And this was designed by Isaac Newton, and there are various types now, and of course obviously they call this the Newtonian. And here you've got, the light comes in from over here, hits a main mirror, the primary mirror, and then comes back to a flat mirror. Now this mirror, this is not a good picture, this has to be curved. So you have a curved mirror that sends the light to a flat mirror, a straight mirror, that sends it out here to your eyepiece. So you stand over here or some way and you're looking boom, boom, boom. You can get a lot more light this way. It can be a heavy device, so you have to be aware of that. It's not as portable, but boy, you can see some. If you're interested in deep space and you don't mind lugging something around, that's the way to go. This is a Newtonian reflector on an equatorial mount, which just means that they got this little gizmo here, which is a heavy weight, so that you can align this to the Earth's North Pole, and then you can, with a motor and software, you can send it to wherever you want. So you don't have to look for stuff. You can put in coordinates so that it'll, if you want to see M13, you go boom, 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 and it goes to that, and it's there. And it'll track. Generally, if you're not tracking and you put something in the scope, the Earth is moving. So what happens is this. So after a minute or so, whatever you were looking at is no longer in the scope. With the tracking, as the Earth moves, the telescope stays on the device, on the object, so whatever you're looking at stays in the scope. So that's one of the features as you start spending more money. This is a Dobsonian, which just means that it's on this gizmo here on a mount, and it's just basically another reflector, but big. This is a red Dobsonian. The only thing there is it's red, but it's a reflector. Main mirror's down here, comes up to here, and then on the other side would be the eyepiece. And this is just a tracking, a spotter scope, so that you don't have to move this around to find it. You look through here to find whatever it is you want to look at, and then you can observe it in the scope itself. And then this is the big Dob, the 20-inch. This is a Dobson, and this here is cloth. So the easy part, and this trailer over here, that's how he brings it. He brings it out in a trailer. But it's cool because it's assembled. You have your stand, you have the main part, and then those poles we saw in that earlier photograph go on here, and then cloth goes around that, so you have the effect of a tube without all the weight and craziness of having this as one piece. He'd have a tough time carrying that out if it was just one piece. So that's the big advantage of what they call a Dobsonian, invented by a guy named Dobson. Then this is the type of telescope that I have, and I got it because I wanted deep space, but I'm lazy and I didn't want to carry anything heavy around. So this gives me the effect of a tube this long and a tube this long. And what we have is, let's see, the light comes in here to a curved mirror that's got a hole in it. And then the light goes from the curved mirror out to a second primary mirror, second primary mirror here, and that shoots it back to an eyepiece here. So it gives me the effect of a refractor telescope where I can put my eyes back here and look up, but I get a longer tube out of the deal. So I get more scope for the size. It's very, very portable. And that would be me and Mark with and this is the solar filter I was talking about. So I've got a tube, it's an 8-inch mirror, and it's, in effect, it's the same thing as if we're a Dobson that was about this long. So that's me getting ready for the transit, posing, and all that kind of good stuff. Side view, as we have known the folks at the Venus transit, and again, looking at the planet Venus
Dave.
crossing the planet, crossing the sun.
It's Dave.
Dave. Okay, yes. I'm sorry. One of the fellows, come on. That was Dave. And then this is a shot of a solar observation from a personal solar telescope. Obviously, you can see the coronas, you can see bursts of magnetism and all that crap coming up, and some sunspots. So a personal solar telescope is about $600 and up. And the disadvantage is that's only good for the sun. But the advantage is you get shots like this. So, well worth it. Things to see. This is the Venus transit. This is a shot actually from the International Space Station. You've got Earth. You've got the planet Venus crossing the sun. So it doesn't happen very often. The next time is in about 105 years. It goes in a whole cycle, which it's a whole cycle of things. But when it does happen, it happens 7 years apart. So in 105 years, it'll go across, and then 7 years later, it'll go across again. And then you'll have to wait, I think, another 200 and some years for the next one. So if you missed it this past June 5th, you missed it. Unless you're very long-lived. So we have meteor showers. Always cool. You don't need scopes. In fact, you can't use scopes unless you're really good. Yes, dear.
Was Venus in transit, was that the one everybody saw a few months ago?
June 5th.
At Edgewater?
At 6:04 p.m. Yep.
Okay, thank you.
That was the deal. Meteor showers are best watched in a very dark area. You want a dark area, and you want the kind of chair that's horizontal so that you can basically lay down and look at the sky. Binocs aren't going to be any good, scopes aren't going to be any good, you just want to watch because they just kind of do choom and they're gone, choom and they're gone, choom and they're gone. So you're not going to track them or anything like that. But we have 4 different meteor showers. Now you can go out almost any night and in the course of an evening see a meteor. They hit all the time, but showers were actually going through clouds of debris and these start hitting. So there's the quadrantid shower in January in Buddhas, wherever the heck that is. The Perseid in August is in Perseus, we just had that. The Leonids in November, I think it's November 7th this year in the constellation Leo. And then the Geminids in December around the 13th, 14th, in that range in Gemini. Find a dark area. I tell you what, we went out to Observatory Park for the Perseids. They left the park open all night for meteor observing. So, look them up on Geauga County's website. Yes, sir.
Where is that park?
Observatory Park is in Geauga County. It's a jaunt. I mean, it's basically 306 down to 6 over to Clay Road and then down Clay Road, and they've got it there. But I mean, if you go to Geauga County Park, Google that, go to their website, and they've got a listing on there along with a map. It's not difficult to find, but it is a jaunt. But if there is a meteor shower, it's well worth it. They'll have the park open all night and just bring out a lawn chair. I mean, blankets if it's a cold night, and if it's clear, you'll see. We went out there for the Perseids. We got out there at 1:30 a.m. and we stayed till about 2:45, and we saw between 45 and 50 meteors, including what I thought were really cool flashes, where basically just do that. And what it is the speck of dust is hitting the atmosphere directly at us. So instead of a streak, which you get with most meteors, you just get a little flash, and it's pretty cool. So yeah, it's worth it to go out there for a meteor shower. And then, of course, in December, we're going to have the end of the world. You want to be ready for that. That should be an exciting event. We'll have parties. I'll be out there with a telescope and a raft, and 2 of each kind, 2 blondes, 2 brunettes, 2 redheads. And this is some of the stuff I've seen. These are, again, this is M13, that globular cluster, 300 to 500,000 stars. This is a wider view of the same cluster. There we go. These are my favorites because I can find them. They're by the Big Dipper. Essentially, you go to the Big Dipper and go to the right out a little bit, and it's there. These are 2 galaxies. They're 15 million light years away. This is known as this is just a spiral. I think it does have a name, but I've never paid that much attention. This is known as the Cigar Galaxy. It's also a spiral, but it's not, it's edge on to us, whereas this is a little bit closer to face on. But they're basically 15 million light years away, and you're looking at approximately 200 plus billion stars here, about 200 billion stars here, but kind of hidden by dust. And if you got a wide enough angle lens on your telescope, you can get both of them in the eyepiece at the same time. Yes?
Why did you call the last thing just a globular cluster and not a galaxy?
Because it's the globular cluster is actually part of the Milky Way. If you think of it this way, the stars in a globular cluster are going around themselves. Okay, they're orbiting around themselves, around each other. They're related. But the cluster itself is part of the galaxy and going around the galaxy. Okay, so it is still part of the Milky Way.
There's a halo of these things around our galaxy. It's sort of
yeah, there's a bunch
and
of them.
Other galaxies too.
M13 just happens to be my favorite because it's fairly easy to locate. But whereas a galaxy itself, a galaxy would be a collection of stars, usually in the billions, whereas the globular cluster is in the tens of thousands or hundreds of thousands.
Can they develop into a galaxy on their own?
Probably not, because they're already gravitationally bound. They'd have to be able to escape their parent galaxy's gravity. So without something enabling them to do that, I'd say no, probably not.
Where did this designation come from, a letter?
It's from a guy by the name of Messier.
What does it all mean?
Well, in the 1700s, 1800s, I think 1700s, an astronomer by the name of Messier sat down and he's looking through his telescope and he started seeing what could be best described as little cotton fuzzies. And they're basically, that's all they are in a small telescope. It looks like a little ball of cotton. And he saw a bunch of them. He didn't know what they were. He didn't have a good enough telescope to figure out what they were. So he started calling them nebulas because they were nebulous. He wasn't sure. They looked like gas of some sort. So he called them all nebulas, and then he started cataloging them. Then, okay, this one's here, this one's always here, this one's here. And then he called this one 1, 2, 3, and so on. And then eventually that catalog became known as the Messier catalog, and so the M is from his first name. However, they're not all just balls of gas. While they're called nebulas, they're divided into balls of gas, but then there's also globular clusters that are basically collections of stars, and then also galaxies. It just happened that they all look like cotton fuzzies in his telescope, so they're all in the Messier, but you can have M81 as a galaxy, M13 is a globular cluster, and then the Orion Nebula also has an M designation, and that's just a gas nebula.
So are there some with other than M?
Oh yeah, oh God, yeah, because you gotta remember, he's using a small telescope in the 1700s. Since then, we've discovered gazillion. I mean, there's over 200 billion galaxies. And there's the Messier catalog goes up to, I think, I'm not sure, maybe 120, something like that. At least 101, I know that, but you know, not that much more. Yeah, there's lots of stuff out there. This is a shot of M81 and M82 in the same frame. And again, they're close enough that with a wide enough angle eyepiece, you can get both of them into the eyepiece at the same time, which is kind of fun. And then here's my favorite during the winter is the Orion Nebula. And you're seeing this at 2 wavelengths. When you go outside during the winter, and if you know where Orion is, if you don't know where Orion is, look up in the, usually it's in the southeast sky, and you will see, although again it goes over of course, but look towards the east, you'll see the belt. See these 3 stars right in a row. That's Orion's belt. If you go down from there, there's this little thing hanging down. They call it Orion's sword. It could be interpreted in many ways, but this thing right here is in visible wavelength, the nebula. It's a gas cloud. It's a star nursery. Stars are being born there. There's 4 stars in the middle that light this up. So that's why we're able to see it, because there's 4 stars behind the gas that light it up. If we were able to see in infrared, this is what we would see. The entire nebula actually encompasses the entire constellation. So when you go outside, not tonight because it's not out, but if you go out, say in December, when the Orion Nebula is available, and you look, you'll see this huge figure, this huge constellation, and know that there's a gas cloud of hydrogen gas that's making stars that's surrounding it, sort of like so. And I like it again because I can find it really easily. And now we'll go into Star's Oddities. And for that, I will turn the presentation over to Mr. Mark Taborski, equally amateur astronomer.
Thank you.
I will return, and I've got a few more things to go over, but I'll wrap it up after my
Might be a good time to go grab a cup of coffee or a cookie if you'd like, because we're going to switch the piece.
Look, I
We're
read
just
that.
record over mine, right?
Yeah.
Can we do that, Ray?
Sure.
And also, for the first part,